And welcoming everybody from my part. Sorry that it's in English. I'm learning Dutch more and more, but yeah, it's not good enough, especially for a technical presentation like for today. My suggestion is like for all webinars which we are doing, that please you mute your phone, your microphones for the moment, and at the end we have time to ask some questions, or you can even type them in if you want via chat. That's also possible, no problem. No, so I will share my screen and hope you can see the presentation. Is it okay?
Yes.
One done.
Yes.
Yep. Yes, you can see it. Okay. So let me start. The topic of today is, as Tuan wrote in his invitation, especially that we are talking about the height reference and measurement, why it's so important at SPI. I have a short introduction also into the topic, explaining a little bit how our SPI is working. So we are also working with Moire, but we reinvited a little bit the Moire technology. We call it 360 degrees Moire. We have one projector and 4 cameras from the side to have no shadow effects. And this 8 times means 8 projectors, 32 cameras all in all. The nice thing is that we have a very, very big head and a very big field of view. We will come later to the point why it's so important. No? This is just as an introduction. Another point, why an SPI is mandatory for the process control. Just again, some basic explanations. You know that with very big components, with 06 or 03, for example, to be very honest, you don't need an SPI. And if you go slower and slower, the paste volume is also decreasing. And then it's becoming more and more interesting and important to have an SPI. The keyword here is transfer efficiency. Means that if you have a big component, again, let's go back to 06, 03, for example, nearly 100% of the paste will stay at the board when you remove your stencil, if you have a stencil printer. Going smaller and smaller, for example, 01, 005, then you have nearly 60% only paste which will stay on the board, and the rest will stay in the stencil. No? I think you all know that. This is also why it's becoming more and more important to clean the stencil and so on from time to time, because you have a lot of paste there. This is not coming from Micronic VI technology, but really from the market, this information. With this transfer efficiency, for sure, the volume is also becoming more and more unpredictable. Means if you have a big component, you don't care if you have a little bit more paste or a little bit less, there's no difference. But if you have a very small one, again, let's go down to 01, 05, or even the 02 or 01, you see that even small changes can make a big difference. This is also coming then to programming, very important, because normally SPIs are like, they're putting tolerances via the JEDEC, means that for this component, for example, you have one tolerance. No? And even from logical point of view, without going too much into detail, you can understand that putting the same tolerance here for the body and for the small leads is not really logical. So what we did, we changed a little bit the way. So we are working with this AAR, area aperture ratio. This is, sorry, I was a little bit too fast, is here. If you take the area from here and the height of your stencil wall, this is a little bit the ratio which is calculated, and we take this as a reference for putting automatically all the tolerances. So what we are doing is, for example, for that one, we put 2 different tolerances. One here for the body and the rest, the second group for the leads. If you have a small chip, for example, it's also in the same group than the leads. We don't care about JEDEC here because we are at SPI level. We just care about these AAR groups. And then the big advantage of that is that you don't need so much fine-tuning anymore. Normally, if you do it by JEDEC, you just put one tolerance and you need then to fine-tune. And at the end, what is happening is that the tolerances are becoming bigger and bigger, and at the end you just have a quite expensive conveyor. So what we are doing is, by putting it via this AAR, we are really going with all yeah, all the sizes of this AAR and very close to and putting realistic tolerances, let's call it like that. So we also, like at the first one, we have a very good first pass yield, but we are also really improving here your process, and not only having a good first pass yield and letting through the SPI going everything which is coming through. Now coming to the topic height reference, because this is let's say the base where the technology is yeah, based on, let's call it like that, the big difference. So how we are working, coming back to the big head, why we have such a big head, big field of view, that's more the right word. If you have a small field of view and you're putting some reference points to know exactly where is my 0 point, having a small field of view, you are forced to put them here. And as you can see, is it really the right place? What we can do, thanks to the big field of view, this is really like it is, comparing to a small field of view. We can put thousands of references on the whole board. And if we, for example, one reference is in the hole here, or is here, for example, it doesn't matter because you have much, or let's say more than enough others which are the correct ones. And then we can directly, by subtracting it, directly find the right 0 point. We'll show you a little bit how that works. So with a small field of view, you need to crop the image around the pad. Then you put some references points here. That's all you can do, because here you don't see anything. You take these reference points and put them on an axis, z-axis, like that. These are all the points you see. And then you create a histogram, right? So the first task, what we do, this is really by, this is exactly what is inside all SPI, all the, let's say the data which are in the SPI and how the calculation works inside, is to find where is the top of my solder deposit. That's quite easy. You see there's quite an easy, yeah, and well, you can see that clearly that this is the top, so that's easy. But then going to the second step is, where is my board? Where is the 0 of my board? And that's then not so easy, because you don't know, is it here? Is it here? It depends a little bit, and we are not 100% sure where it is. And this is especially between, yeah, let's say 0 and 50 microns, sometimes 40 microns, it depends, but it's very difficult to find the right 0 references. So how to solve this issue? Quite easy. We don't take that into account, and what we do, we just put a threshold here. You may know that normally, yeah, you have a threshold which you have to put in your program. Sometimes it's hidden somewhere or put automatically at 40, 50 micron, but it's there. What does it mean at the end to put a threshold? It means that we are not really measuring, we are more calculating. Because the threshold, as you can imagine, you can also put it here or here. So it's a little bit a calculation to have a 0 point. So it's not really measuring. And this is also, yeah, why people say a little bit, yeah, SPI can't see below 50 or 40 microns. We changed that a little bit, again, thanks to the big field of view. So what we second point, we stay at the SPIs with a small field of view. Also for the bare board teaching, so the naked board, you also need to teach that. It's the same here. You take the points, put it on a Z axis, and then you see also here where is exactly my origin. And then what we are doing is, you have the printed board, you have the bare board, the naked board, and you subtract these two information to know exactly where is my solder deposit and my paste. And again, it's not very easy. We don't really know, because as we said before, we don't know exactly where it is here. It's not accurate, and this is why sometimes at SPI suppliers are saying, yeah, we don't really need a bare board, or bare board is optional, because a lot of people are asking us, why do we need a bare board at the Micronic SPI? And that's exactly the reason why. Others are saying we don't need that. But again, it's not another step which you need to do, but it's a very important step. No? So here I show you a little bit how we are doing that. So with the SPI, with the big field of view, we don't need to crop the image around the pad. We can have, as I showed you before, thousands of reference points. We do exactly the same for sure. We put it on a z-axis. And then you see that, sorry, here's the z-axis. And then you see both is easy. Now defining where is my 0 point, it's quite easy, right? Because again, if we, for example, we are 1 point is in a hole or wherever, we just take that out. And we have here the 0 reference, and the solder deposit is also very easy to find. So we have no need to put a threshold. There's no threshold, and we really measure down to 0. That's the main difference and main advantage of our SPI. Especially today, you can say, oh, it's quite nice. But let's say tomorrow, or really in the near future, if you go down and down with the smaller pads, it will, and smaller components, it will become mandatory, and then you will see the differences. We see it even today with 01, 05 in Asia, for example, the mobile phone producers. Here we already see that, you know, today. So same again for the bareboard teaching. You know? So we put them on an axis, on a histogram. As I told you before, we do exactly the same. And here now the subtraction is very easy, because now putting the bareboard on the pasted board, we can clearly see where the 0 point is. We subtract it, and then we know exactly where the paste is, and we are very, very accurate. There's no fine-tuning then later on needed, because the fine-tuning is also because of the threshold, because we don't really know where it is, and then you have to fine-tune here a little bit, next time again. As you are very accurate here, we don't need to fine-tune. Another point of this Z reference and accuracy is the warpage of boards, which can happen. We are doing it differently. That's also a patent of VI technology, one of 17 patterns we have on this machine. You have to understand, like, normally, I don't know if I will jump out quickly a little bit from the presentation. I hope you can see me again, or my video. I will show you that. Now I can see myself, then it's easier. That's the board, that's your board, and then you have a warpage, this direction, for example. This one doesn't matter. Let's do it like this. Yeah, a little bit too much, but anyhow, if you have, for example, now paste here, yeah, your deposit is here, your pad, and you're looking from the top, that's normal, and you see it in the, sorry?
We see only a very small picture.
Oh, I'm sorry, that's not good. Normally you need, what can I do? Can I put it?
Sharing screen.
Can you see? Maybe I stop sharing quickly.
Yes.
I hope that's okay.
Yes.
Can you see me now?
Yes, excellent.
Okay, perfect. Good. Sorry for that. Thank you, Tuan. So here again, so from the top, the pad is here. So you look from the top. That's a perfect angle. You see it. No need to move the camera in Z, whatever. It's fine. But now let's take a pad which is here on the side. What historically was done is that you move the head in Z, right, to be on the focus of the camera, normal. The problem is that you are looking on a different angle here or on the other side than you do here. So you see one side, but the other side you don't see it. So what will you do? Again, you will just estimate. You will say, okay, I see here like 50%. So normally on the other side should be also the other 50%. It's okay. It's quite accurate for the moment. But with the pads or the volumes becoming smaller and smaller, it will be a little bit, yeah, let's say more or not accurate anymore in the future. So what we are doing, we thought about, okay, how can we change it? And what we are doing here, we don't move the head in Z at all. What we are doing is the pad is here. Here also, like always, we just look at the perfect angle from the top. And now the pad is here, we just move with the conveyors, we move the angle of the board. So we take the board and we move it. It's for sure it's not like that. If you have a warpage like that, then you have other problems. You don't need an SPI. But if it's like that, for example, we move it automatically. You don't need to do anything. It's automatically found this warpage and corrected, and means that if I look from the top, it's okay. And if the pad is here, we just move the board like that, and we look always at the same angle. And that's exactly the big, let's say, difference also, and the big wow effect, why we are so accurate. Now I will share again my screen and show you a short movie about that, because I think a movie is always better explained. I hope you can see it. Please stop me, Tuan, again if you don't see it. I click on play. Before clicking on play, you see here that on the top, that's the head. These are the conveyor. They are moving independently, one from the other. And this is the board with quite an important warpage. But this is for test reasons, so it's okay.
Perhaps you can make the screen wider.
Yes, like that?
Yes, yeah, very good. Yep.
Perfect. So I started. I hope you can see it. And you see that this is the head. The conveyors are moving independently one from the other. The head is moving only in one direction, in the Y direction, not in the Z direction. And you see how the conveyors are moving. Again, fully automatic. You don't need to do anything here. That's completely done automatically by the machine. And we are here again looking at the exact angle in the perfect focus of the camera. And this is why we are so accurate. Coming back to my presentation, one of the last slides, what is very important here is at the end, repeatability. This is something which is good and very important as well, but the accuracy is the other part of the balance. And what we saw in benchmarks and a lot of customers worldwide is that repeatability is quite good, but when it comes to accuracy, we are really best in class thanks to these, let's say, new, it's not even a features, new technologies we brought out. No? So it was not just only bringing out an SPI, also to say, okay, now we from VI Technology, Micronic, we also have an SPI on the market, but it was really a little bit a game changer on the market. Let me show you, because I still have a few minutes, very quickly how the review looks like. Maybe you know that this is a little bit how it looked like, and then we said, okay, here we have a very big head, a big field of view, we should do it differently. So what we are doing, or how it looks like, it's like that. And the big benefit here also is time saving, for example, because if you see that all the pads or all the volumes are not good, you don't need to go there, or your operator, step by step, but you can directly say, okay, the whole board here is bad, let's take it out, something happened here. So this is how it works. You can also here measure, for example, the bridge. You have a small bridge here, you can measure it. You have calculation tools, a lot of things, and it's much nicer if you see it, no? Like believing is seeing, or seeing is believing. I don't know which in which direction, but I hope you understand what I mean. Yeah, that's it a little bit for my presentation. Let me thank you for sure for your time, for listening. As Tuan said at the beginning, because I heard that some people joined a little bit later, we are recording this video and we can share it if you are interested. Here you have again our contacts. I think you know at least one of us and know how to contact us. And if you want for sure a deeper presentation with more details or a demo, yeah, then please let us know. Come to our demo office in Eindhoven and we will be happy to show you more. Yeah, that's my presentation. Do you have any questions? Or what? Let's say, what do you think about that? Do you have an SPI, for example? Gerd, I don't know if we know already each other, so it would be interesting to know. Do you have an SPI? Do you see advantages here, or is it exactly the same from your feeling?
We have an SPI. Huh? But I'm interesting. I do the DFM for TVP, and I was interesting for the specifications or the what you can measure and see with the SPI.
Okay, nice. Okay, perfect. Thank you. Yeah, thank you for this feedback. And Allard, you have our SPI, so maybe you as a customer can at least confirm to the others that even if I'm a sales guy, sometimes I'm telling also the truth. But how is your feeling with our SPI? You're using it now for 2 years, I think, nearly, no?
Yes, 2 years indeed. Yeah, we're quite happy with it. We saw, I didn't expect that when we purchased it, that we have more problems from screen printing than I expected.
Yes.
And a lot of problems are now solved because of the SPI. Before we start really assembling the board. So yes, it's easy programming also for the SPI. And I'm now lately I'm looking at all the data of SPI also. I hope there can be a presentation about that also, how I better understand all the CPK's values that I can get out of the SPI also.
Yes, very good point. Thank you for your feedback, because you're right. There are also for sure, this is just a very short part of the presentation, but for sure our SPI can do a lot more. And the most important is not only to find the errors, but also, let's say, to what to do with all the data, no? Because you get a lot of data, which is nice, but the question is, what can I do with that? And here we have a lot of interesting statistic tools also, what you can do with the data, which are quite easy to understand, and that's very important as well. No? So because you're collecting more and more data with SPI, with AY, but at the end we are not there only to find errors. We want to help you to optimize your process, and this means also that we need to give you tools to understand where are my problems. No? Like Allard said, and there's a lot of customers are telling us exactly that. They're saying we have an AY because this is what we need at the end to make sure that our product is good, our end product. But then when they put there an SPI, even for trying, no? So there are customers saying, we are not sure if we need an SPI. We can put it there. Please also here call us if you're interested for a few weeks to try it for free. And then you will see after sometimes even a few days, we had some customers in Germany, after a few days, they said, that's incredible. No, we already changed some stencils and so on because we saw where the problems are coming from now. No? And that's also quite interesting. Tuan, do you want to say a few words more in Dutch or in German or in English?
Yeah,
or German.
Deutsch reden. Now, I think what I also like the point, and which of course is not visible very clear, is the insufficient. And from market analysis it's like the insufficient. So you have too less solder paste on the bed. That is the number 2 of the failures, which is coming out of the stencil printing process. And especially when you have like an 01, 05 or 02, 01, it's very hard to see by eye that you have too less solder paste. Yeah. So I think that is really one of the big advantages of having the SPI, because it's the fundament of the process, and the fundament starts with the stencil printer. Exactly. And the thing is that what you see in reality and practice is that people or companies are reproducing failures over and over again in the process, which are coming out of the end, and then of course the cost is very high to repair it. So therefore, I would say I think it's even better to first invest in an SPI and then an AOI. But I understand, of course, that the AOI is on the list of a lot of subcontractors being forced by their own customers. So that is understandable. But I think there's also why the topic is fundamental. The fundament starts on the beginning, and the same way you're building a house, and when the fundament is wrong, then of course everything goes wrong in the total process.
Exactly. I'm always saying the AOI is for your end customer, and the SPI is really for you to control your process. No? So
yeah, I totally agree. If I need to choose, if I want an AOI or SPI, I would choose SPI.
Yeah, exactly. This is what most customers say when they have both. Exactly. They say we can take out more from the or let's say better results from the SPI than because at the end at the AY it's nice to find the errors, but it's unfortunately too late at the end of the line. And at the SPI you can really save time and money.
Correct. Yes,
that's
correct.
right.
And that's the whole point, right? It's about the area aperture ratio, which is causes for many of the problems
Exactly.
designed into the stencil. So, okay. Now I think there was also the idea of the webinar to have it short and crisp. I think you did a very good job, Tarek, to manage it within the time.
Thank you.
A few words on Dutch. Ik wil iedereen graag bedanken voor de deelname voor de webinar. We hebben er nog enkele meer, nog 5 meer nu op de agenda staan. Deze komen ook op een LinkedIn te staan. Maar goed, jullie hebben uiteraard al een overzicht gehad. En enkele van jullie al ingeschreven in meerdere webinars. Mochten er nog vragen zijn, hoor ik het graag. En we zullen de webinar, de video ervan per link sturen. Dat gaat via Microsoft. Zijn er nog vragen of opmerkingen? Ik hoor niks, dus dan ga ik ervan uit dat het voor nu duidelijk is. Mochten er naderhand nog vragen komen, dan schroom niet om Daan of mij of Tarek te contacteren. En dan hopelijk tot de volgende webinar.
Okay, thank you very much.
Bedankt.
Thank you.
Thank you.
Soon. Bye bye. Ciao, ciao. Take care.
Bedankt allemaal.
Thanks. Bedankt. Goedjes.
Bye bye.
Okay, I think everybody is out. Oh, also Tarek. Ja.
Ik zie bij de opname dat hij 1 uur opgenomen heeft. Ik weet niet wat hij allemaal opgenomen heeft. Even kijken.
Dat vind ik heel raar, want volgens mij begon natuurlijk pas, heb ik hem pas aangezet bij de 30 minuten.
Ja, daarom, maar de meeting stond al 1 uur open, een half uur erin gelogd. Ik zie dat daar iets mee te maken heeft. Je moet even kijken als je hem bewaart voordat je hem deelt.
Ja.
Opname kun jij alleen stoppen.
Ik ben een knopje aan het zoeken. Oh hier, opname. Ik zat een ander veldje openstaan. Opname.